40 years after research began, on April 5, 1998, the world's longest suspension bridge, the Akashi Bridge, was opened to traffic. The Brooklyn Bridge connects New York and Manhattan, and was completed about 120 years ago, becoming the pioneer of modern suspension bridge history. The bridging techniques from that time were passed on, and in 1937, the Golden Gate Bridge in San Francisco, and later on at the end of the 20th century, UK's Humber Bridge, the longest in the world at that time, were completed. The techniques used in building Japan's long-span suspension bridges began from knowledge learned overseas. In 1988, the Seto Ohashi Bridge was completed. Since then, the techniques which were used in the construction of the Seto Ohashi Bridge have drastically improved and now reach world-class standards. And with that, the construction of the world's longest suspension bridge, the Akashi Bridge, began. There are three major routes that connect Honshu to Shikoku. One of these, the Kobe-Awaji-Naruto Expressway, crosses the island of Awaji and consists of two long, large-scale suspension bridges, the Akashi Bridge on the Honshu side and the Onaruto Bridge on the Shikoku side. The Akashi Strait is known for its beautiful scenery. Its width is about 4 kilometers. The speed of the tidal currents there are so fast that they reach a speed of 4.5 meters per second, or 16 kilometers per hour. About 1,400 vessels ply this waterway daily, including large international vessels. The construction of the Akashi Bridge was carried out under such severe conditions. The Akashi Bridge's total length is 3,911 meters, and the center span is 1,991 meters. There are two anchorages that hold the cables on both sides of the bridge. The bridge was designed as a truss-style suspension bridge with two main towers in the sea. These towers rise 297 meters above the sea surface. The girder height was set to 65 meters so that even the world's largest vessels can pass beneath it. The designers of the Akashi Bridge carried out elaborate research on the impact of earthquakes and wind. In 1940, the shocking collapse of the Tacoma Narrows Bridge occurred in Washington, USA. This occurred with wind speeds of only 19 meters per second. For the Akashi Bridge, wind tunnel tests were held repeatedly to ensure that the bridge could withstand windstorms of up to 80 meters per second. Since the bridge pier's site is very deep and the tidal current is very fast, the laying down caisson method was adopted. It was developed in Japan and was employed for constructing the Seto Ohashi Bridge. As the very first step in constructing Akashi Bridge, underwater excavation started the preparations for the main tower foundation. A grab, or bucket crane, which is equivalent to 8 dump trucks, fights against the tidal current of the sea in water 60 meters deep. In March 1989, caissons arrived at the Akashi Strait. These caissons were prepared at a plant to serve as the frame case of the bridge pier. Water was poured inside the caissons to sink them at precise locations, while carefully measuring position and slope. The margin of error was only 5 centimeters. Underwater concrete casting began on the inner caisson. Casting started from the middle, then moved on to the outer circle, taking into account the heat generated when concrete hardens. A special concrete was developed that would not separate from the aggregate even when in water. 9,000 cubic meters would be cast at a time, and each casting would take 3 days and nights. This process was repeated for 1 year. Challenged with the fast tidal currents of the Akashi Strait for 4 years and 3 months, the 2 main tower foundations were completed in waters 60 meters deep. At the Kaiko workstation, construction of the anchorage foundation was progressing. Because the slurry wall measuring 85 meters in diameter, which supports the foundation, was to be located 65 meters underground, it had to be installed before drilling inside of the wall could begin. After a year and a half of excavation, the Kobe stratum was reached at a depth of 60 meters. The next step was to cast 230,000 cubic meters of concrete into this huge hole. To save time, various distinctive inventions were adopted. A massive cable anchor frame was brought to the site. The 140,000 cubic meter concrete casting framework was poured into a complex structure of reinforced steel and iron frames, so a high flow concrete was used. The world's largest anchorage was completed after 5 years. At that time, the blocks for the tower were produced at a factory. Strict standards for construction accuracy were demanded for each and every process of cutting, assembly, and welding in order for the tower to stand perfectly straight. Now the work to erect the main tower could begin. The tower pillar was constructed by carefully stacking the block edge faces. The metal plates needed to fit together seamlessly, so thorough inspections were carried out. After stacking 30 layers of blocks, the gigantic tower was completed. It was 297 meters tall. On a day with low wind speeds, the pilot rope was taken across using a helicopter. The diameter of the pilot rope was only 1 centimeter. This thin pilot rope would guide the massive cables and enable the installation of a catwalk, a workspace in the air. For the first time in history, Honshu and Awaji Island were connected. Cable construction finally began. A 4,070 meter strand that was reeled at a plant was unwound. It was the world's very first high-strength prefabricated strand. One after another, each strand passed carefully across the strait. This is the prefabricated strand which binds 127 wires together. 290 of these strands combine to make up the 112 centimeter diameter cable. A century has passed since the Brooklyn Bridge. The world's highest level strand which connects Tower 3P to 4A. And from 4A, the strand is fixed to the anchorage frame. Since steel expands and contracts with the temperature, workers wait for the night when the temperature stabilizes. Then the tension of the strands are thoroughly checked and adjusted. In the early morning of January 17, 1995, a vertical thrust massive earthquake struck the area surrounding Hanshin Awaji. It measured 7.3 on the Richter scale. The epicenter was only 1 kilometer away from the bridge. Due to the earthquake, the Earth's crust had been altered. The distance between the two towers widened by 80 centimeters. In an instant, the structural calculations for the bridge became obsolete. However, by adjusting the measurements of components which were currently being made at the plant, it was possible to maintain the bridge's safety. For the very first work to be done after the disruption caused by the earthquake was the installation of hanger ropes to hang the girders, followed by the installation of girders. Work to erect the massive girder blocks began in June of the 7th year since construction started. The blocks weighed 1,800 tons and could only be transported by sea. Installation was carried out at 6 points that were not blocking the waterways. The bridge started to take shape as it stretched out from the installed massive block over the waterways. The major truss was installed with a large-scale crane, and then the major horizontal truss, and then the steel deck plates which were to become the road. The entire installation was carried out with extreme care for the vessels passing underneath. The cables are wrapped to protect them from deterioration. First with steel wires, then with rubber, and finally a coat of highly durable Hypalon paint. Suspension bridges are designed to support all of their weight with cables, so implementing thorough safety measures against rust is considerably important. A newly developed air circulation drying system was adopted inside the cable. From the dry air circulation system, which is placed on the girders, air is circulated to keep the humidity inside the cable under 40%. This is especially practical considering Japan's high temperature and humidity. In August 1997, the time came to install the last piece. The girder finally became one unit. After that, the road was paved to await the official opening of the bridge to traffic. Prior to opening day, some 400,000 people crossed the world's longest suspension bridge on foot. A decade had passed since the construction work started. April 5th, 1998 was the day of the opening ceremony. Construction of the world's longest suspension bridge, the Akashi Kaiko Bridge, had called on every bridge building technology known to the nation. Strict monitoring is held continuously in order to maintain the girder service for 200 years. Surveillance systems and inspections by supervising staff are held constantly to check for swelling of the cable rubber wrappings, deterioration of cable band caulking, and loosening of bolts at the cable band, all in order to prolong the operational life of the bridge. Ten years after its realization, the diverse techniques utilized in the construction of the Akashi Kaiko Bridge have crossed oceans again to be used in suspension bridge projects around the world. These techniques are constantly evolving wherever they are used. The techniques that came from the Akashi Kaiko Bridge will continue to evolve, fulfilling the dreams and hopes of people around the world.